Today we're going to talk about the tangent ratio. It's from Chapter 9, Section 4. Your essential question is, how is the tangent ratio used to find a missing side length or angle in a right triangle? So before I start, every single right triangle, actually let's draw a picture of a right triangle. We'll start with drawing some random right triangle. You guys know that this is the hypotenuse because it's opposite the 90-degree angle. And in a right triangle, there's two other angles that we don't know, and there's also two legs, and then the hypotenuse. And there are these ratios that relate any angle to either one of the two legs or the hypotenuse. And there's several of them. We're going to learn about three of them coming up quickly. So we're going to start today with tangent, and then either in the next lesson or the following one, we'll talk about cosine and sine. Okay, and then there's even more, but we won't get into all of those just yet. All right, so if I choose an angle, now I'm going to use this variable, theta, as an unknown angle measure. So think of theta like x. It's just a Greek letter. The Greeks actually came up with geometry and trigonometry, so when we deal with angles, a lot of times we use the Greek alphabet instead of our alphabet. So instead of x, we're using theta. Okay, and if I think about this angle, then I have two legs in relation to that angle. One of them is opposite because it does not touch that angle. So this would be my opposite leg. And the other one is the adjacent leg because it touches that angle. So we'll call this the adjacent leg. That's a J. And the tangent ratio basically allows you, like let's say for example, you knew the angle and the opposite leg, you'd be able to figure out what the adjacent leg is. Or if you knew the opposite leg and the adjacent leg, you'd be able to figure out what the angle is. Or even if you just knew one leg and the hypotenuse, you could then use Pythagorean theorem to find the other leg, and then you could use the tangent ratio. So the tangent ratio is the tangent of the angle, whatever that angle measure is. Okay, and you're going to need to use your calculator on these because you don't know all of these just yet. Is going to always equal the opposite leg over the adjacent leg. That's how you set up the tangent ratio. Now notice what I've just set up is I've set up an equation. And an equation can be solved. So if there's something that I don't know, I can solve for the thing that I don't know. Now tangent is actually a function. That function, so functions have inputs and outputs. Okay, and the input is always an angle. I'm going to write that down. We're not going to do too much this year with this, okay, as far as learning about the tangent function, but or the sine or the cosine functions for that matter. But we will add on to this next year, and then we'll add on even more the following year when you get to pre-calculus and trigonometry. Okay, so I do want you to know that tangent is a function, which means it has inputs and outputs, right? So with inputs and outputs. Now, it just so happens that the input of the tangent function is always an angle. And hopefully you remember what I mean by inputs and outputs. So when you were first learning about functions, probably in algebra or pre-algebra, you would make this input-output table. Sometimes you do it horizontally, right, where you put inputs and then you get outputs. So in this situation, the input will always be theta, and then the output would be whatever tan of theta is. And your calculator can calculate tangent. So on your calculators, which is why for this class you need a scientific calculator, because if you don't have a scientific calculator, you don't have a tangent button. But you can see right here that we've got tangent. Okay, so find that on your scientific calculator. And above that, you have this tan inverse, which we'll get to. I'll talk about what tan inverse means. Not today. I don't think I do these today. So another time. All right. Now, there are little like mnemonic devices where you can kind of memorize things. And the way that we can memorize tangent, that tangent is opposite leg over adjacent leg, we can use this thing called TOA, T-O-A, which basically says tangent goes with opposite over adjacent. And it's actually part of a bigger mnemonic device, and it's not important that you remember this, but you do have to figure out a way to remember that for tangent, it's going to be the tangent of some angle equals opposite over adjacent. You have to remember tangent is opposite over adjacent, because I'm going to give you more. So I'm going to give you sine and cosine, and they're all going to be different legs, and then we'll even bring in the hypotenuse. All right, so let's do an example here. This is actually pretty straightforward. So we're going to find the tangent ratio. Remember, ratio is like a fraction. Well, it is a fraction. It's not like a one. It is a fraction of the acute angles. And then we're going to write as a fraction and a decimal to 4 decimal places. Write as a fraction and decimal to 4 decimal places. So that's the 10,000th place. Okay, so let's see, where did I just put my ruler? That's a good question. Here it is. Okay, I'm going to draw myself a right triangle. I'll make the orientation a little bit different this time. We'll pretend like it's a right triangle. And the way that we'll know that it's a right triangle is because I'll label my right angle. So I'll make this A, B, and C. I'll make one leg 15, the other leg 36, and my last leg 39. Oops, I'm off the screen a little bit. Sorry about that. Okay, so we're going to find the tangent ratio of the acute angles. So there are 2 acute angles here, right? Acute being less than 90 degrees. So that's angle A and angle B. All right, so I'm going to do the tan of angle A, and I'm just writing a ratio relating to that angle, to that acute angle. So when I look at angle A, and I know that tangent is opposite leg over adjacent leg, I have to figure out which leg is opposite and which leg is adjacent. Now remember, 39, this is our hypotenuse. It's not a leg, so just kind of ignore it for now unless we need it to help us find one of the missing legs. Okay, so for A, my opposite leg is the one that's not touching it. So that's 15. And then my adjacent is the one that's actually touching it. So that's 36. So this would be 15 over 36. Then you need to ask yourself, can I reduce that? Yep. You can divide top and bottom. Definitely by 3. I don't think there's anything else. So this ends up becoming 5 over 12. So that's it as a fraction. Now let's figure out what that is as a decimal. So you just basically take the numerator and divide it by the denominator. And I get 0.41666. Well, okay, so that's 6 repeating, right? So I need to go 4 decimal places, and I'm going to look at the one after it, and I'm going to say that's bigger than, that's 5 or bigger, so I'm going to round up to 7. So this is, and I'll say that it's approximately, because that's not an exact answer, 0.1, oops, 4, sorry, I said 1 and wrote 4, 4167. So that's it as a decimal. And now I'll do the same thing with B. So tan of B, or tangent of B, so angle B. And now I want the opposite leg over the adjacent leg. So it's basically, I'm just going to flip this, right? Because I'm doing the other angle. So it's now going to be 36 over 15, right? Opposite over adjacent leg. All right, and then that really gave us 12 over 5. And then we'll do the same thing, and well, that'll be my ratio, my fraction answer. And then let's take 12 and divide it by 5. Oh, and I get exactly 2.4. Probably could have done that in your head. Okay, so you have problems in your assignment that basically ask those exact same directions. All right, let's do example 2. Find x to the nearest tenth. Nearest tenth is 1 decimal place, if you don't know that. All right, and you're given a right triangle. So what I want to do, if I'm given if I don't like have a hypotenuse or another leg that I can figure out what the other leg is, right, using Pythagorean theorem. Let me clarify that. If I don't have 2 pieces of this right triangle, like 2 sides of this right triangle, then I can't use the Pythagorean theorem to find the other side. But I can use the angle. So this is the beauty of these different trig ratios that you're going to be learning about. One of them happens to be tan. And in this scenario, I can use tan of 25 degrees. So I can set up an equation using the ratio that I know is tan. Okay, so tan is the ratio of opposite leg over adjacent leg. So tan of 25 degrees then will be the opposite leg, which is 12, because again, 12 is not touching this angle, over x. And then from there, what you can do is hopefully you can realize, you have a couple options, but one of them, hopefully you can realize, like, okay, there's a fraction there, there's an equal sign, and I can set this up as a fraction as well. So this is a proportion, which really quickly we can solve by cross multiplying. Otherwise, if you don't want to cross multiply, if you don't want to think of it like that, you're just trying to get x out of the denominator, you multiply both sides by x. But that'll give us the exact same answer, or the exact same equation, if I cross multiply. So I get x times tan of 25 degrees equals 12. Now, how do I get x by itself? Well, I'm going to divide both sides by the thing that's happening to x. And x is being multiplied by tan of 25 degrees. So I'm going to divide both sides by tan of 25 degrees. Okay, so the tan of 25 degrees, those reduce. Now you can't just divide by tan, you can't just divide by 25. This is a package deal right here. Tan always has to have an input, and that input is an angle. Okay? People get confused on that. Now, from there, on the right-hand side, I'm just left with x. On the left-hand side, you're like, great, well, how do I divide by tan of 25 degrees? It's actually super simple. So we use our calculator for these things, okay? Later on, down the road, you'll have to memorize some of them, and we'll get to that. And it'll all be based on your unit circle, but we're not going to do that this year, okay? All right, so we're going to take 12, and we're going to divide by tan of 25 degrees. Oh, if you have one of these fancy calculators, you're going to need to make sure that you're in the correct mode. And that's even true on, I think, scientific calculators. So there are 2 modes. I just hit the mode button. And different calculators are going to work different ways. And if you get confused, you may have to Google it. or we can try and zoom it and figure it out. Okay, so notice that I go down and I can either be in radian mode or degree mode. Okay, we're not going to talk about radians this year, so you want to always be in degree mode. So once you hit that, you should be good for the rest of the year. Okay, so 12 divided by tan of 25 is going to give me 25.734, and it said to round to the nearest tenth, so I'm going to look at the first decimal place right after the decimal, look at the number after it, that number is smaller than 5, so I keep it at 7. So it's 25.7, and I'm going to say it doesn't actually equal, but it is approximately 25.7. Okay, so why might something like this be important? Well, a lot of times we actually would use these trig functions. You know, maybe you know the height of something. You need to figure out, hey, if I want a certain angle here, right, how far away do I need to be? Maybe you're tying something to this roof or something. A lot of times, though, it's used actually to help you find the height of things. Okay, so let's talk about that. So that's called the angle of elevation. So maybe you're hanging out. I don't know, you're working on a project or something, right? And actually, I'm going to draw myself a little. I'm going to draw you a little bit shorter down here, a little bit lower. Here you are. Here's, let's say, a tree. Now, you can, from your eyeball, you have this view straight out as a horizontal line to the tree. From your eyeball to the ground is some amount of feet or inches or however you want to say it. You look up to the tree, to the top of that tree. You want to know how tall that tree is. Well, when you look from your horizontal line of sight up to the top of the tree, you create this thing called an angle of elevation. Okay, and I'll put a little theta there. That's your angle of elevation. So if you wanted to figure out how tall this tree was, right, you wanted to know this height right here. From the ground, okay, this is the ground. You could figure out the height of the tree from your horizontal, right, so from this line, this horizontal vision line, you can figure out the height from there up to the top of the tree. I'll call that, how about A? Plus, you can add in this X value that you don't know or that you could measure easily from your foot up to your eyeball. You could easily figure out how tall that is, right? So from here to here is X. So that your height is basically A plus X. And if you know this angle and you know this A right here, or sorry, you don't know that A. You know your length right here. You know how far, right? You can walk over to the tree and figure out how far you are from that tree. Okay, I'll call that B. Then you have the opposite side, or you don't have it, that's what you're looking for. You have the adjacent side, and you would have this angle of elevation. Now, there are these weird tools that we can use to find the angle of elevation. Let's see. Let me actually Google that real quick for you guys. Let's do sextant. All right, so there are these tools which you can actually like look through. I think you look through here, and it'll measure like what angle you are actually looking up. So you could look up at the tree, I think through this little visual thing right here. Here, let me click on this, see if it takes me to a better picture. Oh, no. I just want to see that picture. There we go. That's the picture I want. So I think that you would, am I saying that right? Oh no, here, you look through here. You look through here up to the tree, and then this will measure the angle at which you're looking up at the tree. Now, these were used a lot back in navigation when people were like, before we had technology, a lot of modern day technology, people needed to know where they were when they were out setting sail on the ocean, on the open ocean. So they would use the stars, and then these angles would help them figure out their coordinates on basically on the planet. Okay, so now I do a really, let's see if I can find that for you guys. I do, which we're not going to get to do this year. Oh, here's a good example. So you would look through up to the top of something, and here, look, see, happens to be in the ocean, looking like at a star. Okay, so you look up at something. Okay, that gives you the angle of elevation from that horizontal eyeball viewpoint. Let's see if we can find any other crappy ones that I would be using with you guys in class. We do one in class that uses a straw. Oh, here it is. So we end up doing something with a straw and then a protractor, and then we use a string. So we can look up and use a string to tell us what angle of elevation we are creating. Okay, I'll do one more little search here, see if there's anything else that looks good, but oh, there it is. There it would be. That's exactly what you'd be looking through in class. However, I would have a straw right here, so that would be like your telescope. You can do this on your own. You can build a simple sextant. You can go out and you can measure the height of any trees or buildings or phone poles or whatever else is out there that you want to know the height of. Okay, so it's pretty cool, super useful. However, nowadays we have people that now program our technology to do this. So we have things like fish finders where you can figure out how far down a fish is below you, or we have similar ones for measuring heights of trees for like foresters. So remember though, there's somebody out there that is actually creating this technology, and they're basically using the tangent ratio. Okay, so let's do a problem where we actually look for the height of something. I skip example 3, so we go on to example 4 in your textbook. This is page 490, monitoring progress number 6. So if you were going to watch the video, maybe because you don't like how I explain it, you would not watch example 4's video. You would watch the monitoring progress number 6 video. Okay, so I'm going to open my book to page 490. I guess I could be using the online one, but that's okay. We'll use the textbook right now because I've got it right here. So you're measuring the height of a lamppost. So here's a lamppost over here. Okay. You stand 40 inches from the base of the lamppost. You measure, so there's your 40 inches. So this is you over here. You measure the angle of elevation from the ground to the top of the lamppost to be 70 degrees. So you must be like laying on the ground, or maybe you've got a tool that allows you to put it down flat with the ground. Find the height of the lamppost to the nearest inch. Okay, so first thing I'm going to do is I'm going to draw the lamppost. It's going to be a really bad drawing, but let's just pretend that that's a lamppost. Okay, and then I am standing, or you are standing 40 inches from it. We don't know the height in inches, and we would like to know to the top. We've got that the angle of elevation is 70 degrees. So you can see here that, you've got an angle, and in relation to this angle, you've got the adjacent side, and you're looking for the opposite side. So you would say to yourself right away, this would be a tangent ratio that I can set up to solve this. So I can say, all right, I want to know tan of 70 degrees is equal to my opposite leg, which I don't know, that's h, over the leg that I do know, which is 40. And I'm going to leave the units out when we're all done here. Our units are going to be in inches, okay? All right, so from there, I can see this as a proportion, right? Two ratios set equal to each other. I can cross multiply, so h times 1 is h. 40 times, and I always put the number that I'm multiplying by the tangent function in front, because this is 40 times some number. Tan of 70 degrees is some number. So this would not be tan of 70 times 40. Does that make sense? Like, you can't do the 70 times 40 and then take the tan of that. This is 40. Tan of 70 is some number. Here, let's figure out what that is. It's 2.747. Okay, so I'm going to take that and multiply it by 40. Whereas if I did tan of 70 times 40, that is a different number. That is a negative 5.67. So order is really important here, and realizing what your inputs are and what your outputs are. So this right here, tan of 70, is the output if I put 70 into the tan function. I know you're like, Frisk, you keep saying that over and over and over. There's a reason why I keep saying that over and over and over, because lots of students make mistakes over and over and over with that. Okay, so back to this. I'm going to go back, and so in your calculator, some of you could just type in 40 times tan of 70. That's one way to do this. Okay, and we're going to get approximately, and I always go 3 decimal places if it doesn't tell me what to do. And that's going to be in inches. Oh, excuse me. Okay, so that's my height. Now, other ways that you could have done this was to go back and just do the tan of 70, because you all have different kinds of calculators. So tan of 70, press enter and then multiply it by 40. Some of you will have to put the 70 in first and then hit tan. So you're going to just have to play with your calculator. And like I said, if you need help with that, let me know. Okay, so I think we've answered the question. Let me reread it one more time and make sure that we got it all. It says here, find the height of h of the lamppost, to the nearest inch. You can't go 3 decimal places, because it says to the nearest inch. So the nearest inch is here in the ones place. I need to look at the tenths place. That's 5 or bigger, so I need to round this up. So actually it's approximately 110 inches. That's the correct answer. Gotta always go back and read the directions.